Students, this is Dr.J.Jaya Udhaya, Associate Professor from AC Department. So in this video, I am going to explain how to find out the transfer function from the signal flow graph. Now all of you come to see this question. Find the transfer function for the given signal flow graph. So this is a given signal flow graph. So here, this is R of S. That is node 1 is R of S. R of S is nothing but the input node. Then node 6 is acting as the output node. So this is represented by the symbol C of S. So therefore, we have to find out the transfer function. I think all of you know what is meant by transfer function. So transfer function is nothing but it is a Laplace transform of output divided by Laplace transform of input with all the initial conditions are 0. So therefore, here we have to find out C of S divided by R of S. Okay. So in the signal flow graph, we have to use the Mason's gain formula. Using that gain formula only, we have to find out the transfer function. Okay. So now we will start the problem. So first step, if they given the signal flow graph means you have to find out how many forward path you are having. So forward path means you have to start from input node, then you have to end with output node. So that is a procedure. Okay. So therefore, now you take this diagram. So now you take node 1, node 2, node 3, node 4, node 5, node 6. So this is one forward path. Correct? This is one forward path, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. So this is one forward path. Then along with this, you indicate the gain value for that path. It is given in the problem. The gain value is given between the nodes. Okay. So next, after calculating the forward path, this is one forward path. Okay. So for this, immediately you find out what is a gain value. So first gain value P1. So P1 is equal to, we have to multiply all the values. 1 is multiplied with the 2, then this is multiplied with 3, then 4, then finally 1. Okay. So the gain value is 2 3s are 6, 6 4s are 24. Okay. So therefore we can write P1 is equal to 24. Then next I am going to check what is the next forward path. So the next forward path is node 1 to node 2. Then node 2 to node 5, then 5 to 6. So here the gain value is 1, here the gain value is 5, here the gain value is 1. Okay, so therefore this is second forward path. So you have to find out the gain value. So for the second forward path, the gain value is represented as P2. So P2 is equal to 5. Because 1 is multiplied with 5, then 5 is multiplied with 1. So 5 into 1, 5. Okay. So therefore, in this problem, the total number of forward path is 2. Then next we have calculated the forward path gain, P1 and P2 value. Clear? This is step number 1. Then step number 2. So what is the step number 2 means? We have to find out the individual loops. How many individual loops present in the given signal flow graph. Okay. So now you take, so let us take, this is my first loop, that is node 2 to 3, then 3 to 2. So this is a first loop. Then second loop, 3 to 4, then 4 to 3. This is second loop. Then 4 to 5, then 5 to 4. This is a third loop. The next 2 to 5, 5 to 4, 4 to 3, 3 to 2. This is the next loop. So totally we are having 4 loops. Okay. Then next you have to write down the gain value for that. Okay. So therefore, first loop, the gain value is P11 is equal to, P11 is equal to 2 is multiplied with minus 1. So therefore, we can write minus 2. The second loop gain value is 3 into minus 1, minus 3. Then third loop, the gain value is 4. 4 is multiplied with minus 1. So therefore, minus 4. Correct? Then next fourth loop, P14. So P14 is equal to, now you see the 5. The 5 is multiplied with minus 1. So therefore, we'll get minus 5. Then the minus 5 is multiplied with minus 1. So therefore, plus 5. The once again, the plus 5 is multiplied with minus. So therefore, we will get minus 5. Okay. Minus 5. Okay, so this answer for P14. Then we are calculated the individual loop gain. Okay, so totally we are having 4 loops. The gain value for each loop we are indicated here. Okay, the next one we have to find out the whether we are having any 2 non-touching loops or not. Okay, now you see this is first loop, then this is second loop, then this is third loop, then this one is fourth loop. Correct? Then now you see the second loop is touching with 1 and 2. But this first loop and the third loop is not touching. Okay, these 2 loops are not touching. So therefore, I can write P21. So P21 is equal to, just you have to multiply the gain of those 2 loops. So here the value is -2, here the value is -4. So -2 into -4. Upper value is 8. Okay, so this is a P21 value. So we have calculated the 2 non-touching values also. Then next we have to find out del 1. So del 1 is equal to 1 because now you see you take your first forward path. So in the first forward path, all the 4 loops are touching. All the 4 loops are touching. So therefore we are writing del 1 is equal to 1. Then del 2. Now you take your second loop. So this is a second loop. So in this loop, second forward path, which loop is not touching? Now the second loop is not touching the second forward path. So therefore, I can write 1 minus of -3. Correct? So minus into minus plus. Upon 1 plus 3, we will get 4. So this is your del 2 value. Okay. So after calculating the delta 1 and delta 2 value, you have to find out your del value. So actually del is equal to 1 minus sum of gain products or otherwise sum of individual loop gains. So totally we are calculated for individual loop gains. So that value you have to substitute here. So P11 value is -2, P12 value is -3, P13 value is -4, P14 value is -5. Okay, sum of all individual loop gains plus then we are having 2 non-touching loop. For that the gain value is 8. So therefore I can write del is equal to delta value is equal to 23. Okay. So now I know the value of del 1, del 2, delta. Now I'm going to find out the transfer function using Mason's gain formula. So transfer function is equal to 1 divided by del summation k pk into del k. So this is a formula, Mason's gain formula. So here we are having total number of forward paths are 2 paths. So therefore I can write 1 by del into P1 del 1 plus P2 del 2. Just you have to substitute the values. So P1 value is 24 plus del 1 value is 1. Okay, that's why I'm not multiplying. Plus, actually del 2 value is, what is the value? 5. Sorry, P1 value is 5. Del 2 value is 4. Divided by delta value is 23. So therefore, here 24 plus 20, 44 divided by 23. So this is an answer for this problem. So in this way only, you have to calculate your transfer function. I think this video is useful for you. Once again, thank you all.